My name is Zach, and I'm here to tell you about our brand new feature, Outboard DFU. But before we can really talk about why that's so amazing, we need to understand what DFU looks like now. So let me switch over to my desktop and let's have a look. So here you go. What? But Zach, it's so small I can't see the code. I know! You should never see this code. This is only code to facilitate DFU. Like all of it. There's so much code here. So I guess that's enough for now. Let's take a look at what Outboard DFU looks like and see if we like that better. Let me switch over to that code. Just 1 second. Oh yeah, that's what I'm talking about right there. This is only the lines of code from your program and nothing to do with handling over-the-air firmware updates. How is this even possible? Well, the way that this works is because the note card is working as a programmer. It's working with the MCU, pulling the strapping pins, and loading the program onto it directly. That's how we can get away from having all of the code to manage swapping of memory littering up the code that we really just want to work on, like what you see right here. So before we talk about it too much, let me pull up a couple illustrations so I can describe this a little bit better. Okay, here's an example of the Swan's memory laid out with CircuitPython. You can see at the lowest memory, we have the UF2 bootloader. This would allow you to drag and drop files from your development machine directly onto the Swan, specifically CircuitPython scripts. Right behind that in memory, we can see we have the CircuitPython runtime. Obviously, this executes the script and binds it down to the board. And then all the way at the back, the green page there, that would be your actual CircuitPython script. So now that you've got this idea in your mind of what the memory looks like, I can describe a little bit better to you the way that Outboard DFU works. Unlike traditional DFU that forces you to dedicate half of your system's memory to the new image while it executes the old image in the other half of the memory so they can perform a swap, Outboard DFU allows you to perform a targeted deployment. That's because Outboard DFU writes a page of memory at a time because it acts as a programmer. So it really shines in the world of CircuitPython like we can see here. Instead of me having to get rid of enormous amounts of memory to replace the UF2 bootloader, to replace the CircuitPython runtime, and then finally to replace the script, I can just start and end by replacing the script. Or conversely, if there was a new CircuitPython runtime that came along and it had maybe some bugs eliminated or whatever, I can leave my script up there, I can leave the bootloader on, and I can just replace the runtime. But why stop there? Instead of just replacing the runtime, why don't I just take it to the next level and replace the entire paradigm? That's right. We can compile an Arduino binary and then use a targeted deployment to replace the UF2 bootloader. And then instead of having a CircuitPython application running, we will have an Arduino application running on the bare metal. This can be really important because there are things you can do in Arduino that you simply cannot do in CircuitPython. And also you don't have to pay for the entire overhead of the CircuitPython runtime. This is the example that I want to show today, so let's take it over to the bench and have a look. Finally, we've made it to the bench. Alright, let me show off my CircuitPython application. I've got an LED, I've got a button. I push the button, lights out, I let it go, lights on. Lights off, lights on. Alright, very underwhelming. I get it. I really actually thought that I was going to show you an interrupt-driven LED and light show with the Arduino, and it was just going to blow your mind. But I saw it in real life, and it just does not translate. Super boring, actually. But one thing I did notice while I was playing around is the unbearable overhead that is introduced by the CircuitPython runtime. Let me show you what I mean. Pay attention to that LED again. I'm going to push the reset button on the Swan and let's see what happens. Reset, lights out, let it go, and 1, 2, whoa! That's slow, guys. A microcontroller normally is like this. It's faster than that, actually, the way that it boots up. Let me show you that wasn't a mistake. Let me just do that one more time. All right, push the reset, lights out, let it go, talk a little bit, and wow, that's slow. All right, let's see what's happening just to make sure nothing crazy is going on. We'll flip to VS Code. Yep, that's the whole CircuitPython script. All it does is set up the digital I/O pins and then just sets the light to the state of the button. That's it, nothing else. So there is no big setup or anything slowing it down there. Alright, so I have written an equivalent program in Arduino. This uses interrupts because that was supposed to be the big show, but fundamentally that makes no difference as far as it goes whenever you're looking at lights. But let me go ahead and compile this, and while I'm doing that, I'm going to explain what I'm about to show you. So right now I'm creating an equivalent Arduino binary. It does the same logic, we'll think of it that way. And then I'm going to use our Notecard CLI. This can be found in its GitHub repository, and it has a special utility called binpack. Binpack will wrap up a binary produced by, I don't know, the Arduino IDE, and put some safety rails around it. This allows us to upload it to NoteHub, and then whenever it goes out to different MCUs, it makes sure that there's a match between the two, and just make sure that you're not going to brick a device in the field. Okay, so we already created that, and now let me go ahead and use our Notecard CLI to pack that binary into a binpack. Okay, that was it. There we go. And now I'm going to go over to NoteHub. This is my brand new Blues project that I created just for today. And this is the only device in it, which is the one that you saw sitting on my bench. I'll go to the firmware tab. Surprise, there is no firmware created yet because I just did it and I need to upload it. So I click the upload button. I choose my file. It's going to be in development, Arduino, Blues and it's the binpack file. I'm going to choose that binpack. Alright, I've got it selected, I save it, which uploads it, and it's already there. Like I said, these are super small binaries, so they go around really quick. Alright, so now that that's on my project, I go back to the Devices tab, because basically I could send that same binary out to as many devices as I want. I'll send it to all of them, which is just this one. So let me open up that device, and then I'll go to the Host Firmware tab. In here, I see I've got a Update Host Firmware button. I am offered a list of all the binaries I have uploaded, which is a list of 1. I'm going to select that, and I will say, yes, I want to update to this. And now it's going to go ahead and start working while I'm talking right now. So if you had a bigger binary, you can hit refresh, and you'll see that there's some percentage of it going through. And I'm going to flip over to my bench so we can see what's happening over there. Alright, you can already see that the note card's going wild, blinking, because it's already consuming that binary from NoteHub. I'm also going to point out that there are no additional wires attached. I've got an antenna, a button, a battery, a note card, and a Swan. There is no way to upload new firmware to this except for with Outboard DFU. Okay, so while it's doing that, and you can see that the light's gone out, so it's halted the firmware for the moment so that it can kick on the new stuff. I did make one change so that there's another way that you can see that it's actually running new firmware, besides the fact that it's going to boot up in a lightning fast manner. Whenever I push the button now, the light will come on, and when I let it go, the light will turn out, except for in this first one, just so I make the light come on so you can see how fast this thing boots. Alright, so just to prove it's new stuff, I'm going to push down, nothing's going to change. There it is, I let go, it's going to turn off. Alright, so now it's opposite of what we saw before. genius level stuff here. But like I said, the real kicker is right here. I'm going to push this reset button and then I'm going to let go now. Oh, there it is. But that was so fast. I think it got on before I said the word now. Let's try that one more time to make sure. Push that reset button, it goes out and let go, and oh, there it was already on. So as you can see, the ability to use Outboard DFU to do more than just change your Python script or your same programming paradigm, just to stay inside of there, there's only so much I'm going to be able to tweak my Python script to make it go faster. Sometimes you have to switch away from that and switch in a whole new paradigm, and that's where we can take something like Arduino and just lay it down over the top of what we had there and then get that amazing benefit of just going lightning fast, or some dramatic change that you can only get with a brand new style. But anyways, guys, thanks for joining me today.